Welcome to video tutorials of Indus Gurukul. In this session, we will go through cubes and cuboids. It's part of mensuration from maths. The session is designed mainly for class 9 and 10, where some part of this session is for class 8 as well. Now, do you remember these figures? This is a simple iPhone box or it's a home lights matchbox. So these we have seen in our homes. Not necessarily an iPhone box, it is any mobile box. Now these boxes in geometry are called cuboid. These are nothing but a three-dimensional figure. What is a three-dimensional figure? If you write something on a paper, it is a two-dimension, means only x and y, means length and breadth. But if something has a length, breadth and height also, then it is known as a three-dimensional figure. So these are the three-dimensional figure. These three-dimensional figures are called cuboids. So if we go to the technical definition, cuboid is a three-dimensional shape which consists of 6 faces, 8 vertices and 12 edges. What these edges, faces and vertices are, we will study in next slide. Here we can see there is a picture A, B, C, D, E, F, G, H. So this figure is showing a cuboid where length, breadth and height is given. Now, what is a face, what is a vertices and what is an edge? In this figure, the green colored ones are the faces. These are the side faces, similarly top and bottom and front and back. So it is nothing but a flat rectangular surface of a cuboid. This is known as face. And how many are them? There are 6 in any cuboid, there will be 6. Vertices are nothing but the corners like A, B, C, D, these corners. So in any cuboid, there will be 8 corners. And what are the edges? Edges are nothing but the straight lines which join 2 edges like A to B, B to C, C to F and all. So these are edges. So in case of any cuboid, there are 12 edges. So these are faces, vertices and edges. Now, what is the surface area and volume? Surface area is, in case of a cuboid, there are 2 types of surface area. One is the lateral surface area and the second one is total surface area. When we talk about total surface area, we consider all 6 faces. But when we talk about lateral surface area, then we talk about only the vertical ones. We don't consider top and bottom. So all 6 is total surface area. But if only the vertical ones, front, back, left and right, not top, not bottom, then it is a lateral surface area. Now, if you have to find out total surface area of any one face, because all the faces are in shape of rectangle, so we know the area of rectangle is length into breadth. So automatically the front face will be L into B, then L into H will be the side faces and the top will be B and H. So accordingly, we add all and the total surface area will become twice of length and breadth, length and height and breadth and height. In case of lateral surface area, we consider only the vertical ones. So we will not consider the top one. What is the top one? Length into width. So length into width in both the cases removed. So automatically it's reducing down to this. This is the formula for lateral surface area. And what is the volume? Volume is nothing but just we multiply length, breadth and height of a cuboid and we will get a volume. Now, what about a diagonal and a perimeter? Diagonal, in case of cuboid, if we consider any point, let's for example A, now the maximum possible distance from A to G, F, C, E. Now there are possibilities like here AG is a diagonal which is for the surface, not for cuboid. For cuboid, the diagonal is A to F. A to C, A to E, A to G, these are the diagonals of faces. But A to F, which is from A, the maximum possible distance from A is F. So AF is the diagonal here. And how we can find out the AF? We can find the value of AF with the formula like the AG and GF. Now, if in case of AG and GF, this will be the 90 degree. Don't go through the 2D figure. In case of a 3D figure, this AG is perpendicular to GF. So using the Pythagoras theorem, it is AG square plus GF square. And what is AG square? Because of this rectangular face, AB square plus BG square is simply the value of AG square. So finally, the diagonal reducing down to L square plus B square plus H square root under. So this is for a diagonal of a cuboid, whereas the perimeter is simply the sum of all the edges. There are 12 edges. So out of 12, 4 length, 4 width and 4 height. So total reducing to, this is the perimeter of a cuboid. Now, what is a cube? When all the sides, length, width and height are equal, let's say is equal to A, then it becomes a cuboid. So in case of a cube and cuboid, faces 6, corners 8, sides become A, volume is L into B into H in cuboid, but it becomes A cube. So similarly, all the values changes. In case of cuboid, it's a different LB and H, but in case of cube, all LB and H are same, equal to A. So it reduces down to a formula. Now, let's take a question. We have to find the maximum diagonal of a cuboid of dimension 3, 4 and 5 centimeter, 3, 4 and 12 centimeter. So AB is 12, BG is, it's not given BG is 3 or 4. Let's consider BG is 3 and BC is 4. So simply using the formula L square plus B square plus H square and then taking the root under. So the 13 centimeter is the value of AF diagonal here. Let's take another example where there is a solid cube having a surface area of 486 square centimeter and it is cut into 27 cubes of small sizes. So if a surface area is 486, we can find out what is the side of the cube, because surface area of a cube is 6 into A square. So divide 486 by 6. You will get 81, divide 81 and square root of 81 is 9. So side of cube will be 9 centimeter. If we consider this is a cube, then it is of 9 centimeter. And if we are dividing in 27 cubes, it simply means each cube will be of size 3 into 3 into 3, because 3 into 3 into 3, 27 cubes. So if we are dividing this one side 9 centimeter in 3 parts, each will be 3. So this one small cube will have a surface area of, because now it is separated, so 6 into A square, where A is now A. So it is 9 into 654. So the difference of the area is 486 minus 54, which is 432. So the new smaller cube is 54. Original cube was 486. It is 432 lesser. So what is this percentage value? 432 upon 486 into 100, which is 88.88. So the new smaller cube will have 88.88% lesser surface area with respect to the bigger one. Let's go to one more question. A child is playing with building blocks which are the shape of cubes, and so just read the question carefully, and if you want, you can pause the video and you can solve the question as well. Now, how to solve such questions? What is the volume of the structure? We have to find out the structure of this volume. So for this, we have to find out how many cubes are there, and we have to multiply by the one volume cube to get the total volume. So the answer will be like, one cube will be 3 into 3 into 3, 27, and how many? 3, 4, 2, 3, 4, 2. So a total of 18 cubes. So 27 multiplied by 18 means 486 cubic centimeter is the volume of this all these together. Okay. We are going to the next question again. For the same, you can pause the video, you can read the question and you can answer. in this, the question is asking about what is the total surface area that will be painted. Now, the painting is happening to exposed surfaces. Now, here the key is front, back, left, right, and top is exposed, but bottom is not exposed surfaces. Please understand, because these are building blocks, so you have assembled it, so you can't lift it. It is not intact. So after making the structure, child paints all exposed surfaces. So how to solve such questions? For such questions, we have to understand this in 4 steps of figures. Front and rear. There are how many faces? Because in this, we have to find the area of one face. If it is 3 into 3 cube, then the area of one face will be 9 square centimeter. This all small faces will be of 9 square centimeter. Now, just read this line first. It says, let us find how many faces are exposed from front, rear, top, side, painting and all. So from front, these are we can count, it is 13. So if 13 are from front, automatically 13 are from rear also. So the total number of faces we are adding is 13 and 13 from front and rear. Top face, you can simply, these are the dark blue ones, 1, 2, 3, 4, 5. So it is 5. Right side. Now the point is, from right side, these are 3, but there is one more exposed surface, this one. Just see that this violet color. So 4. And from left side, 1, 2, 3 and 4 again. So 4. So these are the total 39 faces are exposed, but we are not considering bottom because it is an assembly. So 39 multiplied by 9 resulting in 351 square centimeter is the total exposed surface area. Continuing further, this is a question from a classroom. You know that any room is nothing but a cuboid, because a room has a length, breadth and height. So if we have to paint the wall or we have to find out the volume or something like that, we will equate this room as a equate this room to a cuboid. Pardon. So in this question, you read the question. This question says that length, breadth and height of classroom ratio is given. If the breadth and height halved while the length doubled, what will be the change in the area of 4 walls? Please understand it. It is not talking about floor. It is not talking about roof. It is talking only about 4 walls. To solve this to solve this question, you can pause the video. Otherwise, if you have already solved the question, proceed. Now let's consider the length, breadth and height of the room as 3, 2 and 1 unit, which is very easy to solve. So in this case, this is for example 3 units, 2 units and 1 unit. So if we have to consider the 4 walls, this will be the surface area of 4 walls, which is nothing but simply 4 square units. The blue colored ones in the picture, these 2, and then front and back. So these are 4 walls, 4 square units, part 1. In part 2, what happened that in the previous one, 1 unit versus 2 units and length, what happened in the next? Area of 2 opposite was, so there's nothing but the continuation of previous one. In here, we took the left ones as blue, whereas in this, we took the green ones. So the blue ones are adding to 4 square units and the green ones are adding to 6 square units. So total is 10 square units. So this is the area of original classroom. Now after changes, if we go for changes, after changes, let's say this is the new dimension where the length has been doubled, height has been half and width is also now half. So similarly calculate the total surface area, and this is now 7 square units. So earlier it was 10 square units and now it is 7 square units. So what's the reduction? 3. And a reduction is in terms of percentage is always calculated on bigger value. So the decrease will not be 3 upon 7, it will be 3 upon 10, which is 30% decrease, because reduction is always calculated on bigger value. So this is 30% new classroom wall area will be 30% lesser with respect to the previous one. Now, moving further ahead, let's try to solve this question. You read it, pause the video, read it, try to solve it, and then process. Here, there are small red cubes of size 1 into 1 into 1, whereas this blue cube is of size 3 into 3 into 3. So how many such small cubes are required so that the new one is also a cube? Now, this to solve, if this dimension is 3 into 3 into 3, it means this volume of this one is 27. Now, if we put one cube left side and one cube right side, so the new dimension will become 5. And because the new volume is again a cube, so it will be a cube of dimension 5 into 5 into 5. So the new cube will be a dimension of 5 into 5 into 5. So the new volume will be 125, whereas the old volume is 27. So the difference is 98, means the volume difference of the new cube and the old cube is 98 cubic units. Now the cubes we are adding is of 1 into 1 into 1, means 1 cubic unit. So how many cubes required? Obviously 98 cubes required to cover this one, so that the new cube is a different color cube. Moving ahead with one more question of same type, little bit tougher. This one, read the question and try to answer again. Here, all sides of a solid cube of side 4 into 4 into 4 colored green has been cut in small pieces, something like this. So if it is a 4 into 4 into 4, how many cubes will be there? New one, total 64 cubes will be there. But the question is asking how many are two-side colored. Now, let's try to solve this. For any cube, we know that there are 6 faces, 8 corners and 12 edges. So, all the cubes, those are on corners. They will be 3-side colored without any confusion. So, if we have to find out 3-side colored, it will be simply 8. Which is not our question, but we are just getting it so that the next time if we get a question like this, we should be able to answer it. Now, if 2-side colored, any cube, like these blue cubes, those are on edges other than corners. There will be 2 surfaces exposed and these will be of green color. So in this case, 2 cubes on the edge. So how many edges? 12. So 12 multiplied by 2 resulting in 24. So answer for the question will be 24. If we have to find out that how many are one-side colored, so that this light green colored ones are one-side colored. And how many? There are 4. So 4 in one face, and how many faces? 6. So 6 into 4, which is 24. So if we have to find out how many are one-side colored, it is again 6 into 4, 24. If we have to find out no side colored, a cube which is no side colored, now if we try to cut the cube in between and try to see this, you see the interior one, these 4 cubes on this side and automatically 4 on this, these 8 cubes are no side colored. Means simply whatever the length, if we subtract 1 from this side and 1 from the other side and we cube it, which is 2 cube, so the 8 is the answer. Or we can do this way, the total number of cubes 64 minus 3 side colored minus 2 side colored minus 1 side colored will give me a cube which is no side colored. Because whenever we will cut a cube, we will get either 0 side colored, 1 side colored, 2 side colored or 3 side colored. So in this way, we can find out all the possibilities like 0, 1, 2 or 3. Accordingly, if the side dimension changes also, we will be able to find out if we solve in this way. So that is all for the session. If you have any query or doubt, you can send a WhatsApp number or a WhatsApp message on this number. You can give a call on this number, but you will not get any help regarding any question on this number. For help, give a message on this one, or for anything regarding the program or anything else, you can give a call also on this number. Thank you.